Okay, this is a Tuesday, Hyperbola Notes 27, Section 2, page 369, 6AB, 8AB, 9, 10, 11 through 15. Okay, so number 6, it's asking us to complete the square. 4x squared minus y squared minus 16x minus 4y minus 4 equals 0. And we're going to graph it and do all that fun stuff. So how do I know this is a hyperbola versus an ellipse or a circle? Well, you look at your two squared terms, and if the numbers in front, the coefficients, are different, then it can't be a circle. And if it's a minus, it's a hyperbola. If that was a plus, this would be an ellipse. That's all. So without even looking at anything else, you can tell by the first two terms. So this is a hyperbola, okay? So we got to make it look like a hyperbola. So we're going to group our x's, just like we did with the ellipses and the circles. And then we're still going to put a plus sign here just for a second. I'm going to show you why. Go ahead and group your y's. And your y's are negative y squared minus 4y plus blank. And then I want you to add 4 to the other side because it doesn't have an x or y, so we add this to the other side. So we have this. So we're going to take a 4 out, just like we did in the ellipses. We're going to take that GCF out and get x squared minus 4x plus blank. Now, the reason why I put a plus here is because that's about to change, because I am going to factor out a negative. Now, we're just factoring out a negative 1, right? So if it's a negative 1, you don't really need to write the 1. So basically, by factoring a negative out, a negative divided by negative is a positive. A negative divided by negative is a positive. So by taking the negative out, it just makes both terms positive, where they were both negative. All right, and then we still have 4 plus blank plus blank. So it's time to complete the square. So what's half of negative 4? It's negative 2. Negative 2 squared is 4. So what am I adding to the other side? 16. You are right. And then on this one, what's half of 4? 2. 2 squared is 4. So what are we adding to the other side? Negative 4. So this is the only time that you will ever add a negative to the other side is when you have a hyperbola. It's the only time. Everything else will always be a positive number when you move it to the other side like that. All right? So now let's go ahead and complete our squares. So we have the square root of x squared is x. Half of negative 4 is negative 2, which is also the square root of 4. Minus, because that's got to be a hyperbola. That's very important. We have that minus in there. And then half of 4 is 2. Make sure you put a square there. Or the square root of 4 is 2. You can either do half or you can do square roots. And then when you add these, the 4's cancel, and you end up with 16. Just like in an ellipse, a hyperbola also, standard form, we like that to be a 1. So we're going to divide everything by 16. And we're going to end up with x minus 2 squared over 4, because 4/16 is 1/4. Minus, nothing cancels the 16 on this one. So it's just 16 equals 1. So here is your standard form for number 6A. Now, we need to graph it. So do your x and y axis. That was, my lines weren't too good there, were they? Okay, so my center is, like, find your x, go take the opposite of the number with x, find your y, take the opposite of that. So my center is 2, negative 2. So just like an ellipse, that's not going to change. So there is my center, 2, negative 2. So we want to label it 2, negative 2. Now, unlike ellipses, you don't have major and minor vertices. You just have vertices, and there's only the positive ones. So I'm going to circle these. Your vertices are only going to be the ones that are positive. Like this negative right here, these are not going to be vertices. Just this. So the square root of 4 is 2. And since it's under x, we're going to go right and left 2. So your vertice is 4, negative 2, and then 2 the other way, which is 0, negative 2. Now, your hyperbola is going to open like this, and like this, because those are your only vertices. Now, I'm saying that those are the only vertices, that you usually don't have to use this, but we do the box method. And the box method does want you to graph the vertices and draw a box. So even though the hyperbola will not open from these, we're going to use these to draw a box. So we're going to use that plus or minus 4 going up or down, because it's under y, from the center. 1, 2, 3, 4. 1, 2, 3, 4. I'm making them green, or maybe even put an X there so you know that these aren't your vertices. They're just there to help you draw a box. So I'm going to, with a pencil here, draw my box. You don't want this to stand out like it's the main part of the problem, but we do need a box. And each of the vertices should be the middle of the box. So that center should be nice in the middle of that rectangle. So now comes the asymptotes. Your asymptotes go from your center to the corner of each box. There's your asymptotes. Make them nice and long. And then place your pencils at those vertices. Remember the 0, -2? And you want to go up to the asymptote without touching it, because these curves should get increasingly closer to these lines called asymptotes without touching them. So there's the first curve. And then your second curve start at 4, -2 here. Not from the center. Do not start from the center. Start from your vertice. Go up towards the asymptote and then kind of curve it around like this. Make sure they're nice and smooth. And that's your hyperbola. Now, so I did say that my vertices were 0, -2, and 4, -2, but we don't have to write the green ones. We don't have to write the vertical ones. Foci points. C squared equals A squared plus B squared. It actually is the Pythagorean theorem. So this is 4 plus 16, which is 20. And 20, the square root of 20 is 2 radical 5. Square root of 20 is approximately, let's look, square root of 20, oops, that's not square root. Square root of 20 is about 4.5-ish. So from the center, we're going to go where the curves open, 1, 2, 3, 4.5. Go back to the center and count 4 the other way, 2, 3, 4. Make sure you're not counting from the vertice, you're actually counting from the center. And there's your foci 1 and 2. And how do I write those? Well, they're on the same line. Again, notice they're on the same line, the same y. So these are all going to have -2 as the y coordinate. So I'm going to write that for my y coordinate. Okay, oh, the comma goes here. -2. -2. It's the 2 of the center that's going to change. So it's 2 plus or minus 2 radical 5. Those are your foci. And one last thing. How do you write the equation of the asymptotes? So give me 1 second. I'm going to get the notes that I passed out today. So you're going to notice in the notes here, let me find these. Oh. So this is a type 1, because I go left and right. It's a type 1. So I'm looking at type 1 right here. See the type 1? And you're going to go transverse axis, all this stuff. You're going to come down to the asymptote equation. It's right here. Y minus k, so I'm going to write this down. Y minus k equals plus or minus b over a, oops, you can't see this, b over a x minus h. So I'm writing all this down. It's right on your paper. You'll get good at these after a while, and you won't need the paper. All right, so what does this mean? So the k is the y coordinate of your center. So it's y minus -2. Okay, it's y minus -2. That's the y coordinate of your center. Equals plus or minus b. Now this is b. The square root of that's b, so that's 4 over the square root of this, which is 2. Because it's not b squared over a squared, it's b over a. Okay, so can you see this? So it's 4 over 2, and then it's x minus the x coordinate of your center, which was 2. So these two negatives make a positive. 4 divided by 2 is 2, and x minus 2. And then you have y plus 2 equals plus or minus, I'm going to just, let's separate this right now. So let's do the positive first. So one of your equations is y plus 2, 2x minus 4, and y equals 2x subtract 2 minus 6. So one of your equations is this, and I'm going to go right to this part, y plus 2, and let's think of it as a negative 2 this time. So y plus 2 equals negative 2x plus 4, subtract 2, y equals negative 2x plus 2. So these should be the two equations of your asymptotes. Let's see if that makes sense. 2x minus 6. So let's go over here. So minus 6 would be 1, wait a minute, what am I doing here? Negative 6. 1, 2, 3, 4, 5, 6 right there, and the slope is 2. Up 2 over 1, up 2 over 1, up 2 over 1, and it's this first line is correct. The second line was y equals negative 2x plus 2, so the y intercept is 2, and the slope would be negative 2 over 1. So it's a little off, but it's right there. Negative 2 over 1, negative 2 over 1, negative 2 over 1. So it's right on my two lines, and isn't that a lot harder than just drawing a box? Okay, it's a lot harder than drawing a box. So how could you figure this equation and line out without doing all that hard work? So you're looking at your lines. I can just tell it right now that the y-intercept is negative 6, right? And the slope is 2. So I could just write y equals 2x minus 6. And the other one from the box is y equals negative 2x plus 2. If you look at this, it's going through 2 right here. And it's going down 2 over 1, down 2 over 1, down 2 over 1. You could actually figure these out without doing all that work. All right, that's how you do asymptotes. So that's 6A, woo! So here's what it looks like in the book. You guys see that? See, they kind of label it right. They kind of label everything right in the problem. So the graph paper that's provided in your book, that's what it would look like. Okay. Okay. I like this, by the way, in your book right here. I like this little picture right here. It tells you what your equations of your asymptotes are. That little part, math tip over to the right. That tells you about your asymptotes a little bit. So look at that when you have a chance. All right, let's do 6B. All that for one problem. Isn't this fun? So much fun to do these problems. All right, 6B. So the problem is negative 4x squared plus y squared plus 32x minus 12y minus 32 equals 0. It looks like the y squared is going to be the positive term this time, so I'm actually going to start with the y squareds out front because I don't want to start with the negative out front. Okay, can you guys see this? I'm starting with the y squareds. Okay, you guys good with that? Now the x's, put a plus, and then put negative 4x squared plus 32x plus blank, and then this equals 32 because we added 32 to the other side because that 32 doesn't have an x or a y. Now, nothing needs to be done with the y's. There's no GCF. It's a 1. It's what we want. So we can start completing square with this one right away. So half of negative 12 is negative 6. Negative 6 squared is 36. So this is going to be y minus 6 squared. And we are adding the 36 to the other side. There's nothing out front here. So we are adding the 36. Okay, now for the x's. So I'm going to factor out a negative 4 because you can't do a difference of two squares with something other than 1 there. So we're factoring out the negative 4. That gives you a positive x squared. And what is 32 divided by negative 4? You're right, negative 8x. So we have negative 4. What's half of negative 4? Oh, so I said the answer. What's half of negative 8? Negative 4 squared is 16. So we are adding negative 64 to the other side. A negative. Again, we only add negatives in hyperbolas. We never, ever will have a negative other than a hyperbola like this. And we're going to complete the square. So we have the negative 4 out front, and then half of negative 8 is negative 4. Put a square. And if you add all these numbers over here, what do you get? 68 minus 64. I think that should be a 4. Divide everything by 4. So no change in the first one. But the 4s will cancel in the second one. So what's going to go on the bottom? 1. The 4s cancel. Equals 1. Because those 4s cancel. And this is your equation. Now this time, notice the y is the positive term. So this is going to be an up and down type 2 hyperbola. first the center. Now, sometimes people get the center wrong because they want to do this one first, but you always have to locate the x. The opposite of the number with x is 4. The opposite of the number with y is 6, so the center is 4, 6. 4, 6 is right here, and that is your center. Okay? Now, vertices, again, there's only 2, and they have to do with this term right here. So a squared is 4. So a is plus or minus 2, and we're going up and down. We're going up and down 2 because it's under y. So from here, we're going to go up 2, and that's 4, 8. And we're going to go down 2. So 4, 8, and 4, 4. So your hyperbola is going to open from the 4, 8 and the 4, 4. Okay? But we're going to create a box. So the b squared is 1. The b squared is 1. So b is plus or minus 1. So from the center, we're going to go 1 to the right and 1 to the left. Oops, maybe that one's about right there. There's your box. So your asymptotes from center to each corner. And this time the hyperbola is going to go up and down. Oops, I just hit the asymptote. That's not good. This would be a point off right there. See that? Don't hit the asymptote. So maybe I need to make my asymptote a little bit straighter. Oh, there we go. Maybe it was just the asymptote wasn't straight enough. All right, so there's your asymptotes drawn in. There's your hyperbolas. These are called vertical up and down hyperbolas. And now let's find our foci points. So c squared is 4 plus 1, which is 5. Did I tell you that in a hyperbola that the a squared isn't always the biggest number? In a hyperbola, the a squared is always the one that goes with the positive term. So it doesn't have to be the bigger or smaller one. All right, so c is radical 5. So radical 5 is about 2.2 from the center. So the vertex was 2, so we only have to go slightly above that and slightly below that for our focus points. So right there and right there. How do I write that, you might ask? Notice that in the center and the vertices that all the x's start with 4. Well, so that's the case for your foci as well. That is also going to start with 4. So write your center 4, 6. 6 is going to be 6 plus or minus the radical 5 for your focus. And that's how you do that problem. Okay, did I have to find the asymptotes? Did it ask me to do that? Oh, it does say find the equations of the asymptotes. So this was type 2. So type 2 is y minus k equals a over b. So it's just like the last one, except that it is a over b in the vertical ones. We want the positive one first, not the negative one. So the center was 4, 6, so it's y minus 6 equals a or b. So a is 2, because the square root of 4 is 2, and the b is 1. Oops, I need parentheses, not equals. And then this is x minus 4. So you put your center in there. We need a plus or minus. So we have y minus 6 equals 2 times x minus 4, and y minus 6 equals negative 2x minus 4. So this one's going to be y minus 6 equals 2x minus 8. Add 6, and this is one of your equations. And the other one's y minus 6 equals negative 2x plus 8. Add 6. So the other one is y equals negative 2x plus 14. That's your asymptotes. Okay, first page done. Turn the page. All right, number 8. It says in number 8 that the center is 1, negative 3. One focus is negative 3, negative 3. And one vertex is negative 2, negative 3. What are the coordinates of the other focus and the other vertex? So let's look at this. they want the other focus, focus 2, and they want the other vertex first. So let's graph what we have. It doesn't say you have to graph. I'm telling you, the graphs really help. So the center is 1, negative 3. This is the center. And they said the focus is negative 3. 1, 2, 3, negative 3. That's a focus, put an F there. And the vertex is negative 2, negative 3. So basically, because this is the vertex, it's going to look something like this, where the focus has to be inside. So from center to vertex, what is that distance? 1, 2, 3. So if you count 3 the other way, you'll get your other vertice. So that looks like it's 1, 2, 3, 4, 1, 2, 3. So your other vertice is 4, negative 3. And then if you count center to foci, that's 1, 2, 3, 4. So count 4 the other way. 1, 2, 3, 4. So that would be 5, negative 3 for your other focus point. So your graph would look something like this. This is focus 2. You guys see how I did that? The center was 1, negative 3. So I counted 3 this way, so I counted 3 this way for your other vertex, and that's where I got 4, negative 3. And the foci was 1, 2, 3, 4 away, so I counted 4 this way, 1, 2, 3, 4, and that's how I got the 5, negative 3. So that was 8a. Now, what is the equation of the hyperbola? How did you determine this? So which type is this, type 1 or type 2? You're right if you're saying type 1. So type 1 looks like this. Go to your notes. This is type 1 where the a squared is under x. So you're going to write x minus h squared over a squared minus y minus k squared over b squared equals 1. And you're going to fill in what you know. So what do we know? We know the center is 1, negative 3. So it's going to be x minus 1 squared minus y minus negative 3, which is going to end up being y plus 3 squared equals 1. Now, what is a squared? Well, a is the distance from center to vertex. So a, in this case, is 3. So this becomes a 9, because from center to each vertex is 3 units. So if you square that, you get an a squared of 9. Now, I'm going to have to apply my foci formula for hyperbolas to help me find my b squared. So my c was the distance from the center to the foci, which was 4, if you count. So since c is 4, you put 4 squared here. A, again, don't forget, a was 3, that's center to vertex. That goes here. So this is 16 equals 9 plus b squared. B squared equals 7. Put a 7 there. And you are done with A, 8A, and 8B. Okay? 9. How does increasing the value for A for the hyperbola given by this affect its graph? What happens as A gets larger? What happens as A gets larger? It's getting further away from the center. So I would say, so like if you had a center right here, if you increase this to here, okay, these are just getting further away from the center, right? If you're increasing this, right? So I would say number 9, you can get this off Desmo also. Increasing the value of A stretches the graph. Horizontally. I don't think I spelled that right. Horizontally. Yeah, I think I did. And increases the distance between the vertices. Does that make sense? It's increasing the distance. Like this major axis is getting further and further and further and further and further and further. So again, the transverse axis, you can say the transverse axis is getting longer. They're getting further apart. All right, that's 9. Woohoo! Do I have some room on the back of this? Okay, I'm trying to turn this paper. Can't do it. All right, so now we're on, is 10 one of your homework problems? Sure is. 10. The asymptotes of a hyperbola are y equals 4/3 x plus 4 and y equals negative 4/3 x plus 4. What is the center of the hyperbola? How do you know? If you just graph these, here is the y-intercept 4, and the slope is 4/3. 1, 2, 3, 4. 1, 2, 3. And then down 4, 1, 2, 3 here. So there's that. Oh my God, can you not even see what I'm doing here? Sorry. I graphed the first one right here. Sorry, you couldn't see that. Here's the y-intercept 4, and then up 4/3, down 4, left 3. So there's the first asymptote. The second one is also got a y-intercept of 4, but it's got a negative 4/3. So you go negative 4/3, up 4, left 3. You draw this one. So basically, your box, if you had to draw a box, would look like this. So what's the center? It's right there. Boom. It's 0, 4. It's the y-intercept of both of your lines in this case. So 10 is done. 11. So when it says 4 is the constant difference, set 4 equal to 2a. It's definition. It's right in your notes somewhere. Let me see if I wrote that somewhere. I don't think I wrote it. I'm trying to think where it's at in here. I'm sorry, I'm not sure I wrote that in your notes. But it's just like the ellipse. If I say constant sum, it's 2a. If I say constant difference, it's 2a. So anytime I use the words constant sum or constant difference, you divide by 2. They're like telling you what the a is. So in an ellipse, I don't know if I should draw this for you or not. Let me see if one of the ones I've drawn already. Let's go back to the one. This is number 6. I'm going to show you this picture. So foci. So what you do with the foci is you can pick any point on a hyperbola. I'll just pick this point right here. See this point? And if you found this distance right here and the distance from this, so basically it'd be the bigger one. It would be this distance right here minus this distance will always equal your transverse axis 2a. So this long one minus this one will equal this 2a right here. This little segment right here, which looks to be 4. So if I did the distance formula from this point right here to this focus point, distance formula, found that distance, and then subtracted this distance, it will always equal the transverse axis 2a. So the constant difference, you might want to write that somewhere, the constant difference in a hyperbola is always equal to 2a in a hyperbola. And the constant sum, I think this is on your test too, constant sum in an ellipse is also equal to 2a. So whether they use difference or sum, you say 2a. Back to 11. All right, so it says 4 is the constant difference of the distances from a point xy on a hyperbola. And it says the foci are located at 0, 3 and 0, negative 3. So let's draw out what this means. 0, 3 is here, that's a foci, and 0, negative 3 is a foci. So what's my center? Just by looking at that picture. If you're saying that the center is 0, 0, you are correct. This is my center. Now it's also saying, in the very first thing, it says constant difference is 4, so a is 2. I can also, because my vertices have to be with the vertex, the foci right here, I'm going to count 2 up, and that's a vertex, and I know it's going to look like this. Go back to your center, go 2 the other way, and that's my other vertex, so it needs to go like that. So that's what my picture is going to look like. Okay, and I'm pretty sure in number 11 they want us to write an equation. What else did they tell us? All right, so I think we're ready to write an equation. This is type 2. Okay, this is type 2. So again, if you look at your notes under type 2 right here, the up and down type, the y is first. A squared is with the y. I'm going to write this equation down. Y minus k squared minus x minus h squared, a squared b squared equals 1. Your job is to write this equation, but fill in h, k, a, and b. So what do we know? We know the center is 0, 0. So that part's easy. When the center is 0, 0, that's good. All this equals 1. Don't forget to put equals 1. Now we know a is 2. So we know a squared is 4. That goes with the positive 1. So how do we find b squared? Well, we need our old trusty foci formula. What is c again? C is the difference from center to foci. How many numbers is that? 1, 2, 3. So C is, so where A was 2, C was 3. Okay, because that's the foci distance from center. So this is going to be 9. A was 2, so A squared is 4. And B squared is 5. There's 11. And 12. Next paper, we're going to do some graphs here. Number 12, x squared over 25 minus y squared over 16 equals 1. So this is a left and right hyperbola because the bigger, or the positive number is the x. So it's going to go left and right. So it's going to look like this. Keep that in mind when you do this. So the center is 0, 0. Count 5 to the right for x. Count 5 to the left. Those are your major vertices. That's where it's going to be opening up from. But before you do that, you need to graph your fake or your other vertices, even though they're not really there, which is the negative ones. So those are going to be 4 and negative 4. And they're under y, so we're going to go up 4. But I'm going to put like an x. So don't go from these, but we need these for our box. Okay, I'm going to draw my box. Draw your nice asymptotes. Center. Don't hit the. If you miss that corner, I'm taking points off. So don't miss the corner. Might need a straight edge if you're not good at drawing lines. So my nice asymptotes. Now go to where your 5 and negative. Remember your 5 and negative 5. Go to those. Don't go from the center. Go from the vertices and draw. Make sure those curves get as close to those asymptotes as you can. Okay, and all right, so your foci, well, first of all, let's go. Your center was 0, 0. Your vertices were 5, 0. Let's just put plus or minus 5, 0. Your foci is c squared equals a squared plus b squared, which is 25 plus 16, which is 41, which is plus or minus 41. So that would mean that your foci points, so we got this as an answer and this as an answer. Your foci points then would be plus or minus square root of 41 and 0. If I asked you to plot those, the square root of 41 is probably like around 6.5. So go 1, 2, 3, 4, 5, 6.5, about right there. Foci 1. Go 1, 2, okay, this is 5, so 6.5 is about right here. Focus 2. There would be your foci points, but this is how you write them. And your asymptotes. You can kind of tell by looking at this one, nothing fancy here. The y-intercept is 0, and the slope is up 4 over 5. So 4/5 x plus 0, and the other one would be negative 4/5 x plus 0. You won't really have to do any work when the center's at 0, 0. You just look at the slope. So in this case, it's b over a. B over a, plus or minus. All right. 13. You guys asleep yet? I feel like it's midnight. Minus x plus 3 squared over 9 equals 1. Let's get our graph ready. This is going to be an up and down one. How do I know? Because the y is the positive term. So this is going to be an up and down one. So let's start with the center. Again, people messed up the centers on these because they want to do this one as the center, like 2, -3, but it's not. It's -3, 2. You always find the x. So the center is -3, 2. Center. And your a squared is equal to 16. So a is plus or minus 4, and we're going up and down. 1, 2, 3, 4. 1, 2, 3, 4. Those are your vertices. Those look to be 1, 2, 3. So those look to be -3, and we added 4 to the 2, so it's 6 and -3, -2. These are your vertices. Now the box. So the box, we need this 9, or the square root of 9, which is 3. So go right 3, left 3. Draw a box. Asymptotes. And your hyperbola, be careful here, is up and down. So you're going to go up and down. Like that. Foci points would be c squared equals a squared plus b squared. So it would be c squared equals 25 because that's 16 plus 9. So c is plus or minus 5. So if we went up 5, 1, 2, 3, 4, it'd be right there and right here for your foci. How do I write the foci? It looks like they're all on the line -3. So the x looks like it's going to be -3 for your foci. So take the y coordinate of your center and add and subtract 5. So what would that be? That'd be -3, 7. Since it's not a radical, you should probably tell me what it is. And -3, -3. Those are your foci points. Oh, this homework's too long. I'm sorry. I'm dying here. 14. We're almost done. 14 and 15, and then we're done. Good thing, 'cause I'm running out of paper. 14. I'm doing this on the other side. 14. Problem is -x squared plus y squared plus 4x minus 4y minus 1 equals 0. I'm starting with the y squareds on this one because they're the positive one. And then I'm going to put the -x squared and the positive 4x in the parentheses over here. And I'm going to add 1 to the other side. So what's half of -4? -2 squared is 4. So add 4 to the other side. Now this one, we're going to have to factor in -1 out first. So that makes that x squared minus 4x. So half of -4 is -2, and -2 squared is 4. But we are adding a -4 to the other side. So this one is y minus 2 squared minus x minus 2 squared, all equals 1. Now, if this was a plus, this would be a circle, but it's not. It's a minus, so it's still hyperbola. The center is 2, 2. You're going to go up 1 for a vertice and down 1 for a vertice. So it's going to be opening up and down. Hello. And then you're also going to go for your box vertices, 1 and 1 this way. Draw a little 1 by 1 box here. Actually, it's like a 2 by 2 box. Draw on your asymptotes. Remember, because the y is first, it's going to go up and down. So your graph looks something like that. Foci points, a squared plus b squared would be 1 plus 1, or 2, which is about 1.4. So you go to your center, go about 1.4 here, 1.4 here. There's your foci. And let's write everything. Center is 2, 2. Vertices are 2, 3, and 2, 1. Foci would be, notice the thing that's the same as all the x's, so keep that the same. Take the y coordinate vertex and add and subtract radical 2. Okay, so this was type 2, and we have to do the asymptotes too. So this one's the one where you want the A over the B. You can look right at your notes to get that. Your center was 2, 2, so this is y minus 2 equals A, which is 1 over 1, and x minus 2. So it's y minus 2 equals x minus 2, and y minus 2 equals negative x minus 2. So this is just y equals x. Does that look like one of the lines? Yep, that does look like one of the lines. Y equals x. And then this one, first thing you have to do is distribute the negative, and then add 2. So y equals negative x plus 4 for the other asymptote. These are your two asymptotes. You gotta split that plus minus up. You gotta split that plus or minus 1 up. This is the positive one, this is the negative one. Distribute the negative. Okay, last problem, 15. Now this one doesn't have a constant, but that's okay because we're going to make a number over here. Group your, there's only an x squared too. So nothing with the x squareds. Put the y squareds in here and add the 18 over. Okay, so the x squared stays by itself. Take a negative out of this. That's y squared minus 6y plus blank. So we're not adding anything from the x. You can't see what I'm doing. I'm so sorry. All right, let's try this again. X squared plus negative y squared plus 6y. Group your y's. Add 18 to the other side. You cannot complete the square in terms of x, but you can factor that negative out of the y squared, which turns that to a positive and that to a negative. And half of negative 6 is negative 3, and negative 3 squared is 9. But you are adding a negative 9 to the other side. So this is x squared minus y minus 3 squared equals 9, because 18 minus 9 is 9. Divide everything by 9. And this is your standard form. What does that mean? It means your center is 0, 3. It means you're going left and right 3. Left and right 3 for your vertices. But it also means you're going up 3 and down 3 for your box points. Asymptotes, asymptotes, asymptotes. And you're going up and down. Whoops, that wasn't very pretty. And your foci, c squared equals 9 plus 9. C squared equals 18. That's 3 radical 2. So we went to the right and left. Let's see, your center was this. Your vertices, I never said that, what your vertices were. Your vertices were, we started at 0, 3, and we went 3 to the right. So that's 3, 3. And we went 3 to the left, and that's negative 3, 3. If you notice, in all 3 of these ordered pairs, center and vertices, everything, the y coordinates are 3 in all of them. So in your foci, they're also going to have a 3 in the y coordinate. And you're going to take this x, 0, and you're going to add and subtract 3 radical 2. So I really don't need the 0 in there, but I do need the plus or minus 3 radical 2. So it's plus or minus 3 radical 2 and 3. That's your foci. Done. 44 minutes later.